Hey there everyone, welcome back. And in this video, I'm going to talk about an interview question, a very popular interview question on immutable objects, right? So I'm sure that you know how to create immutable classes in Java. And if you don't, that's a very important interview question. Even I'm going to cover that in this particular tutorial, but I'm going to ask you a few interview questions that you might usually get in your Java interviews. So basically, before I get started with this particular tutorial, the question that I'll be specifically discussing here is how to prevent your immutable object, how to prevent your immutable class objects. Imagine if you have nested objects inside an immutable class, how you'll be protecting that, how you'll be preventing those objects to be get changed. Well, these questions will make so much sense after some time. So let me get started with the actual topic. That's basically the immutable objects, right? So before we get started, here is a very simple question. What is immutable objects in Java, or what do you mean by immutable objects? Pretty simple and pretty straightforward answer. Once the object is created, it cannot be changed. Well, once the object is created, it cannot be changed. Okay. If you see the Oracle documentation, now here goes the definition. Once the object is constructed, its state cannot be changed. Well, pretty straightforward. Let me prove that with an example. Then I'll come back to my question, which is a very popular one, very important FAQ for interviews. Even I got personally asked this particular question so many times in interviews. So I will be giving you an example. First, let me prove this particular definition that we have discussed on this immutable object. Once the object is created, it cannot be changed, or once the object is created or constructed, its state cannot be changed. What do you mean by the state of an object? Well, so I got a class here called class app, public class app. I will be doing one thing here. I want to have a main method inside this particular class. And I want to create some object here. And obviously we need to create objects, means we need to create a class. So let me go to this interview questions project. And I got a folder here called source. I just created a package here to save some time. And I'll go here and I'll be creating a class. Let's say the class name is student. Very simple. Now in the student class, let's say I got a variable. Private string student name, okay, and another one private let's say int id, okay. Then two variables I have, private string student name and private int id. Maybe I'll generate the getter and setter for this. I'll hit Control+1 here and I'll do create getter and setter. I'll do OK, and I got the getter and setter for my id, get id and set id. And also let me do the same thing for the student name. I'll create the getter and setter for the student name. The shortcut that I hit here is Control+1. Okay. So, well, I got the ID and name, the getter and setter created for these particular variables. I got this object called student. Now let me go to my app.java class. Here, if I'll be creating a student object, student is equal to new student. Let me say student Avilash. My name is Avilash. Hey, I forgot to introduce myself. Hi, my name is Avilash. So basically I'm creating a student object here. Can I minimize everything? Now let me do Avilash dot set ID. Now let's say the ID is 1. Now Avilash dot set student name, and the student name is Avilash Panigrahi. All right. So now if I'll be printing the student sysout in Avilash, okay. Now if I'll be printing this Avilash, then what will happen? Let me run it as a Java application. Now I am going to get my student object printed here. Well, it's printing the address of the student. I just want to do one thing. I just want to have a toString method because I want to print the content of a particular student. So right click, source, create toString, generate toString, generate, Control+S, go back to your app.java. Here I'm printing the Avilash instance right now, which is this one. Now let me run this. Obviously I'll be getting ID as 1, name as Avilash Panigrahi. Now this is the state of my object right now. this is my object is looking like. ID is 1 and name is whatever, right? Now let's say, if I want, I can change the state of that particular object. I can change the state of this particular object, whatever the object that we have right now here. How? So basically, if I'll do right now, Abhilash dot set ID, and I am changing the ID. I'm changing the ID just right here. Now again, Abhilash dot set student name, and I'm just making it, let's say, Penny. So right now, if I'm going to print the Abhilash object again, sys out and Abhilash, all right. So this instance I'm printing again here. And now if I'll be running this particular program, you can see the ID and the name is changed. And I'm basically printing the same instance here. Let's see here, Abhilash. And here also I'm printing the same student instance, which is Abhilash, right? So line number 12 and line number 17, I'm printing the same student instance here. This is the object, and I'm changing the object state. My object was in a state previously. Now I have changed the state of that particular object. That's why this class is not immutable. This is mutable class, because I'm able to change the state of that particular object, which is this guy. Here I'm creating the object, one student object, and I'm changing the state of the object right here. Okay, I have initialized, then I am changing the state. So right now, let's say immutable, that's not an immutable class, that's a mutable class. Then how to convert this class immutable? Well, right now immutable means you cannot change the state of an object. Remember, come back to that definition again. Once the object is constructed, its state cannot be changed. Well, once the object is constructed, its state cannot be changed. So object is created means it should be there in the same state. So to do that, I'll come to student.java. Here I'll be creating a constructor, because when the object will be constructed, this particular variables will be initialized. And to do that, I'm going to create a constructor. Can I do right click, source, generate constructor using fields? Where is that? There we go. Now using ID and student name, I'll be creating a constructor. I'll remove that super. There we go. So right now, here only, right, I will be initializing my student during the time of object creation. So I'll be going to app.java. Right now this student is giving me a problem because I don't have a default constructor available inside student.java. So let me go there and give the ID. The ID is 1 and the name is, let's say, whatever I used to give previously, Abhilash Panigrahi, right? And I will be removing the setters from here, because the setters I have removed, because anyhow I'm initializing here only, right? 1 and the name is this one, so I don't need any setter. But still we got the same problem. Here I'm printing the Abhilash instance here. So I will be getting 1 and Abhilash Panigrahi. Then I'm changing the instance again, the value of the instance, and obviously that instance will be changed. Run this. Well, it's changed, right? 2 and Penny. Previously the object was in different state, and now someone is able to change the state of the object by using these setters. Right now the setters are creating problem, right? Because we are giving the setter. So once the object is created here, now someone has created the object, and we have constructed the object with whatever the value that we have for the ID and name. Right now somebody again is changing the ID, again changing the name, what we do not want. So someone is using the setter method because we have the setter method here. If I do control click, we got the setter method here. So what I will do, first of all, we will remove the setter method. And one more thing we will do, we'll make this variable final. Okay, final means, right, nobody will change this particular ID and student name again once this gets initialized. If you remember, here we got the constructor, right? Using this constructor, someone will be initializing this ID and student name. Come back to the app.java. When someone will be writing this particular constructor, the ID will be 1. The value will be Abhilash Panigrahi for name. If I do control click, this constructor will be get called, and obviously the ID and student name, whatever will be getting, will be set to this dot ID and this dot student name, right? Once this is initialized, once these values are initialized, I don't want to give any setter method right now. Anyhow, we are getting error here. You can see in line number 18 we are getting an error, and in line number 25 we are also getting error. Why? Because the student name and ID, they both are right now marked as final. So my compiler is complaining because anyhow we are constructing the object here, right? Now if you are constructing the object here, then the ID and student name will be initialized, and once they are initialized you cannot change the ID and student name, right? So why you are giving the setter? Remove the setter, right? You don't have any someone will not have any chance to use the setter method, because obviously we are not giving any option to the user to change the value, because we mark this particular variables as final. If it is final, once the object is constructed, right here, once the object is constructed, this value will be initialized, and if this will be initialized, obviously you cannot use the setter again, right? So I just remove the setter from here. Now if we'll go to the app.java, you will be seeing right now here we are having the problem in line number 12 and 13, because we are using avilash.setID, avilash.studentName previously. So right now we don't have any setter, right? So obviously right now it's complaining that, well, you don't have setID and setStudentName. So basically if you don't have this method, how you'll be using it? So let me remove it. Now obviously I'm not giving any chance to the end user to change that ID and name. Once the object is constructed, okay, once the student object is constructed, the value, the one and this particular name, this cannot be changed. Okay, so now this particular class is kind of looking like an immutable class. If you do Control S here, now if you run this particular application, obviously you can see that previously the object was one, and Vilas Panigrahi is the name. Later, whenever we are again printing it, obviously we got the same value because we have not changed it, and we don't have any option to change this Vilas object right now because there is no setter method available. So now the thing is that, okay, is this class student is right now immutable? All right, so right now by looking into our student class, it looks like that we have converted our student class an immutable class, so that my class object once constructed, its value cannot be changed. And of course, yes, we don't have any setter here for our variable ID and student name, so that nobody will able to set the value for this ID and student name. And obviously, even though they will be able to set value, our variables are marked as final, so it cannot be reinitialized again. So it looks like we are done. There is one more thing you have to do. You have to make sure that your class student should be a final class, so that no other classes can extend our student class, and if they will be able to extend, they can override our methods or our variables, and they can change the property in different manner. Well, I don't want to give you half information. I will come back to this particular thing again. Why the student class is marked as final? When you are creating a immutable class, your class should be marked as final. But why? Why is that? Your interviewer may counter you, right? We will talk about that in the next video. But right now, let me come back to the question that I've asked you during the start of this particular video. So 3 things you have to keep in mind. This variable should be final, no setter method, and your class should be a final class. Your class should be a final class in order to protect this class to be subclassed, right? So we do not have give any opportunity to the other developers so that they can extend to our class and can override the getter and the setter method and or the variables or whatever, right? So this class cannot be subclassed, so that I'm using final keyword over here. Cool. So now if I follow these 3 things right now, I feel that my class student is immutable. Okay, so this is what the rule says, right? But now your interviewer will counter you. Okay, so you feel that your student class is kind of immutable, right? So we'll say yes, it's immutable. If you create an object of this particular class here in line number 8, this object you cannot change, right? You cannot do like once the object is constructed, you cannot do avilash.set. Setters we do not have. So how you'll be change the object state? Right argument. Now your interviewer will counter you. Okay, let's say we got another class which is a mutable class. Let's say every student has an address. Okay, he got ID and student name. Let's say he will tell you that, okay, I have another requirement. I want to store the address of the student. You'll say, okay, I'll go and I'll create an address class. Now he'll say, okay, don't make the address class immutable. The address class should be mutable, right? The address class will not be immutable. So he'll say, okay, no problem. I'll just create a class called address. So what are the properties you need in the address? So let's say I want private string, state I want to store, and private string city I want to store. So a student city and the student state I want to store. So I have taken two variables here, city and state. I'll go to source and I'll do generate getters and setters. I'll select everything. I'll do generate. So I got the getters and setters here. Maybe I'll create one more constructor to initialize my variables. So I'll go to source. Where is that? Generate constructor using fields, and I'll do generate, and there you go. So I got one constructor called address, which is going to take two parameter, city and state, and which will be initializing the city and state just right here. And also I have given the getter and setter for my address. Perfect. So this is my mutable class address. Okay. Now this class is mutable. Let me do one thing. I'll go to student.java. Right now, every student should have an address. So what I'll do private address and address. I want to store the address of a particular student, and obviously the student class is immutable. So I have to make sure that this class should be, all the variables of this particular class should be final, right? So line number 7, I have made it final as well. Right now, this guy is complaining that, well, you have to, if I'll hover here, it's saying that initialize the address inside the constructor, because if I'll do equal to null, the error should go. Why? Because right now the address is initialized, and once initialized, the address will not be changed because it's marked as final. So what I need to do, I should not initialize here to null. My student should have some address. So what I'll do, I'll take an address parameter here in the constructor, so address, and what I will do, I will initialize this address right here. So this dot address, which is this guy, is equal to whatever you will be getting from the constructor. So address here, close it, there you go. All right, so right now what we can do, I will go to my app.java, and right here my student class constructor is broken, obviously because we have added a new field called address. And right now if I'll go to the student class, now our constructor has 3 parameters. So let me pass in an address for a student as well. So I'll go to app.java. Here I have to pass the address object. Okay, so now let me create an address object to pass in here. So let me first remove this line number 10, not needed. Right here in line number 8, I'll say address is equal to new address. Okay, let's say address, I'll say home address. All right, is equal to, I'll be initializing my address here. Let's say the city is let's say BBSR, and the state is Odisha. All right, so I got the home address of the student. Let me pass this variable right here, Control S, right? So now in line number 9, I'm constructing my student class, right? My student class constructor will take 3 parameters. One is ID, then the name, and then the address. Okay, so if I'll go to my student class right now, obviously this constructor will come into the picture. Whatever we are giving right here in the parenthesis, it will capture that, and you will be assigning all these things to here. So now what I need, now here you see, here is the interesting thing. First of all, let me override the toString here as well, because right now the address is not here, right? I also want to print the address. So what I will do, I'll just generate the toString again here. So generate toString, generate, Control S. Now ID, name, and address it is going to print. And in the address class also, if you go to the address class, There also we need to have a toString if I want to see the content of the address. So right click, go to source and do a toString. I'll do OK. So now go to app.java, do Control S. Now let's print this Abhilash instance here. This Abhilash is this guy. Cool. So now let me run this. Okay. Now here is the result that we are getting. Okay. ID is 1, name is Abhilash Panigrahi, and the address is, city is BBSR, and state is Odisha. Now my object is constructed. My student object is constructed, and once it's constructed, the value will not be changed, right? Now you see here. Now your student object, once it's constructed, the value of the student object should not be changed because that's the immutable object. Your student is basically a immutable class. Here is final, here is final. There is no getter and setter. Obviously, I need to generate the getter only. So let me generate the getter for this address. I have not generated the getter. So maybe I'll just create the getter for the address. So I can see get address and get name and get ID. I only have getters here. Fine. That's perfect. Alright, so now this particular class does have a problem. Okay, a very important question to understand. You see here, right now it looks like my class is immutable and I have followed all the rules to create the immutable class. But right now you have to see here that the address instance that you are having here, the address reference that you are having here, this is marked as final inside the student class, which is the immutable class. But this address is not a immutable class. This address is a mutable class. We have getter and setter and everything. So now what I can do, just look at here. So basically I can go to app.java, right? Here I'm constructing my student. Here I'm printing my student. So I'll do Abhilash dot get address, right? The immutable class should have getter method, right? So I'm just using get address right now. Now I'll do what? I'll store it somewhere. Let's say address. Okay. Now I have a hold to this particular address object. Okay. Now I have access to the address of Abhilash. This Abhilash is this guy. The address that he got, home address, which is this one, right? Home address is this one. This address I got here, right? Now let me do one thing. I'll do address dot set city. And I'll change the city to, let's say BLR or BLR, that stands for Bangalore, and the address dot set state to Karnataka, let's say. All right. So right now, if I will run this application, you will see that, okay, I'm not printing it. So let me print this Abhilash instance again. This is my Abhilash is my student class instance, which is a immutable object. So let me print that sys out that student object again. Okay, run this. There you go. Now see the address. This is your first version of the student. ID is 1, name is Abhilash Panigrahi, address is BBSR in Odisha. The state is Odisha. The next one, again another student object. The ID name is remaining same, but see here the address, I'm able to change the address of that particular student, right? Right now, the student address is changed. Right now, how you can say that your student class is a mutable class? Because right now you are creating your student class object here. So once you create an object, once your object is constructed, that cannot be changed. That is the immutable object behavior, right? But right now, here you see, once your object got created, I have written some line of codes here, and that is actually changing your immutable behavior of your object. So what I did here, so if you see, I've just created a slide for you. Where is my slide? Okay, there you go. The first slide, you just see that. So first we got our object called Abhilash. Now he got an ID and name and the address. The address is basically another object. The address is the city is BBSR and state is Odisha. Now this object is constructed, and once it's constructed means it cannot be changed. Now someone is doing Abhilash.getAddress. Right now, it is basically asking for this address. Just give me that address. So we are going to give him that address. So address. So right here, he got a reference to this particular object. Right now, what he is doing, he is trying to change that particular object. Right now, you see address.city, set city. He's setting it to BLR. Address.set state. He's setting it to Karnataka. So basically, set city, set state, the setter method, we can have the setter method inside a mutable object. The address is mutable. The address is not immutable. But the address instance, the address reference we have inside the student object, which is an immutable object, right? The student is immutable. The address is not immutable, right? So inside the address, we can have getter and setter, everything. Now here inside the immutable object, which is the student object. Now here what we are doing Abhilash, this instance dot get address. We are getting the address, storing it with a variable. And once we get a reference to this particular object, now we are changing the city and state. And obviously right now the city and state of that particular address will be changed to whatever we have changed. Right now, your immutable property, your immutable class property, the behavior is broken, right? So your class student is no longer a immutable class. This is your question. Basically, I have taken 20 minutes to explain this one. I'm sorry. So now you see, you have changed the property of your class, your property of your address object. So now your student object is no longer a immutable object because of this 3 lines of code that we have written. Okay. And how you will be protecting it. Now, if I run this, you see, now you see the address is changed for the student object, right? So the same student object, again, I'm able to modify its content, which should not be done. So how we will be protecting this kind of scenario? And that's the question. Well, let's look at the answer for that then. All right, so right now here is the question, how we are going to protect our class, right? How we are going to protect our student class, which is an immutable class. Once the object is created, it cannot be changed. But right now someone is able to change the address object content, even after the initialization, what we do not want, because our property is getting broken, right? And to do that, to give you the solution, I will again take you to my slide. Where was my slide? Okay, there you go. So right here, am I recording? Okay, all right. Okay, so the next thing, if I will run this slide again, the fix for this is, now here you see, now here is my object. Okay, so this is the complete version of my object. Okay, so right now this address is basically, holding this particular object, isn't it? Internally, the address is not a primitive type, it's a class type. So it's holding an object internally. So right now, when someone is going to do Abhilash.getAddress, what we will do, we will not give the direct access to this particular object. When he will be calling our getter method, we will not return him the exact object that our address instance or our address reference is holding. Okay, what we will do, we'll just give him a copy of this particular object. Okay, the similar object only, whatever address object we have internally, the same object will copy it and we'll give it to this guy who is basically asking for the address object, right? So right now, this is a similar object which looks like this. Right now, my address is holding this particular object, which is my original object. But right now, someone, when he will be doing a get address, I am not going to return him the original object. I will be returning him a clone, or I'll be returning him a new object or a similar object which has exactly similar content as this object. Right now, if this guy is taking a hold of this address instance, and if he is trying to change the city and the state, the problem will be, right now the city and state will be changed off this cloned object or this new object that we have returned to him. Internally, whatever the object we got, internally, this address, the student class address, this Abhilash is student class reference, right? So this is our student object. This student address variable is containing this object, and we are not giving anybody this particular object. We are giving a fake object. or a cloned object or a new object which is similar to our object. We are giving that kind of address object. So if someone is trying to change, obviously the object that we have inside our student for address, whatever the object we have, that object property is not getting changed. The cloned object property is getting changed. Now let's implement it. Hopefully it makes sense. If I'll clone it, it's gonna make a lot of sense. So code matters, right? We have to see code, right? Talking will not help. Okay, so now let me go to the app.java. Okay, so right now I'm not going to change anything in this app.java class. In this class, I won't be changing anything. Just for clarity, I'm running this again and I'm printing my student object 2 times. Previously, my student object version was this, and later I have changed this version to this one. The address was getting changed. So this is a different version of that particular student. So the object is getting changed. Right now, what I will be doing, okay, now who is the culprit? Who is the culprit here? This guy is the culprit, line number 15. Because whenever he is doing avilash.getAddress, I'm giving him the address object back. And right now, once he gets the hold of that address object, he's changing the content. Well, he is doing it by using this get address, right? Click here. Okay, so here in the line number 26, we are returning the address object directly. So this address, the address it hold, that object we are giving him directly. We don't have to give that object directly. We'll create a clone of this particular object or a new address object with the same content, and we'll give that object back to the calling method, whoever is calling that. So right now the get address, whenever someone is going to call it, I don't want to give a address. I don't want to return him the address object directly. I'll create a new address object. Okay. And I'm going to use the address object constructor. And you remember, if I click here, the address object constructor I have created few minutes back, it is going to take a city and a state. Okay, just right here. So now if I'll go to student.java, right here, the student name, the city is going to be whatever the address is containing. The original address is containing get city. That particular city and the original address, I'll say address dot get state, right? The original address state and the original address city. With that, I'm going to create a new address that's going to be the exactly similar address. I mean, in that address, you're going to have the similar city and the similar state, right? A sample, a copy or a clone of our original address object. With that only, I'm creating a new address and I'm going to return that to this whoever is going to call this get address method. Now you see, if we do Control S, if we'll go to app.java, and right now if we're going to run this particular program, see right now, look at your address previously, look at your address, whatever you had before, and both these objects are exactly same, and the person who is trying to trick our application right now will not be able to trick it, because right now my student class is completely immutable, right? It's immutable, and even though this address, if I'll do get address, and if I click on this address object, this is not immutable. Even though this address is not immutable, still we're able to protect our immutable class, which is student.java, which the student.java is an immutable class, and having a mutable reference. This reference is a mutable reference and it's gonna hold a mutable object. So even though someone is trying to change it, then we will do what internally, this get address method is not going to give the exact object what the address is holding. Rather, whatever the address is holding, with that content, we are creating a new object right here in line number 25. With that content, whatever the address is having, we are extracting the city and the state and creating a new object and returning it back to the user. So if he wants to trick our application, he'll not be able to do it, right? Hopefully it makes a lot of sense to you right now. Your interviewer will ask you a lot of counter question. And before I go into that, I just want to give you a small trick, maybe if still it is confusing. What you can do basically, the address object that you have here, right? Inside the student class constructor, just right here, you are creating a student object, right? and you are giving the ID, the name, and the address. This is the address. Okay, now what you can do, you can print it just right here, sys out address object, okay, 1, and you can basically print the address reference or the address hashcode, because if you're going to print the reference, obviously we have overridden the toString. It is not going to print the object address, rather it is going to print the content of the object. I want to show the hashcode, so I'll just do dot hashcode of that particular object. Why I'm doing it, I'm going to let you know. So in line number 9, see what I did. For the home address, I'm just getting the hashcode. And also line number 16, I'm getting the address of object again. I'm getting the address back from the Avinash instance. The Avinash is basically your student class object, which is having the address. So that address, I'm also want to print it. Sys out. All right. And I'm going to say address object 2. And I'm going to print that address hashcode, right? All right. So now I told you, right, previously with that diagram that I have shown you. Okay, so if you see the second example here, now imagine you got your immutable object, which is your student object, which got an address, and this address is mutable. And right now someone, when he does avinash.getAddress or student.getAddress, at that time we are not returning him the exact object, rather we are creating a new object and we are returning him that one. So in that case, this address that he is going to get, this address is basically a different address object, isn't it? So right now this object is a different object and this object is a different object. So now if you are going to go back to your code, here I'm trying to print out the hashcode in the line number 17 from this address instance. So I'm doing address.hashcode, and in line number 9 right here, I'm also doing home address, which is this one, right, dot hashcode. And you'll see that both the address object are going to be different and you'll be having different hashcode. You can see this hashcode and this hashcode is different, right? And this confirms that we are getting a different object, because this getAddress method is basically returning you a new object. You see, a new address object. So obviously it's gonna be a different address object, right? So previously what we used to do, remove this address. Previously we used to do this one, return address. Directly we're returning the address, right? In that case, we are not able to protect our immutable class. So if we'll go back to app.java and if you run the same code, you will be seeing that right now you are getting the same hash code. Okay, same object someone is able to get a hold of here in the line number 16, and that's why he is able to change the content of that particular object, whatever your immutable object is referring to. And obviously that's why you can see the content of the address is getting changed. Previously it was BBSR in Odisha, later it's changed to BLR in Karnataka, and this address was a part of your immutable object, what was student, and you are actually having that problem. That's why right here in the student class, instead of returning the address directly, I was doing what? I was returning a clone of that. I was creating a new address with the content of the older address that we had. Or you can just do a directly clone here. That's also going to work. Well, right now, this is the explanation how we are going to protect our immutable class. But your interviewer might counter you with a different question. Then he'll ask you that, okay, I understand you are able to protect your application and you protect your, immutable object. But what about the code reliability? Do you think this code is pretty reliable? Do you think this code is good coding? Do you think this is standard approach to do it? Then obviously the answer should be no. This is not a standard approach to this code is obviously working, but this is not standard. Why? Well, what is the problem that we have? You can tell your interviewer that, okay, this code is not standard. That's because what about someone else will give me a requirement tomorrow that in your address.java, here in this address class, I want to include a new variable. I want to include a new variable, just like private string country. Right now I want to store the country of a particular student. Okay, then obviously you need to include this country field here, right, in the line number 7. Now if you are doing it obviously in the constructor also, right now you have to change it to string country. Okay, because obviously you will be initializing that country, so country, and you will be doing this dot country is equal to country, and there you go. So right now here is the problem, and obviously you will be creating the getter and setter for this country because it's the immutable, it's not an immutable class, it's a mutable class. The address class is a normal class. So let me create the country for that, the getter and setter for this country. So if we'll go down, we got the getter and setter for the country here, and maybe right here I will be generate the toString again because it's only got city and state. So let me just do right click, source, generate toString, and please generate that with all the 3 fields, city, state, and country. Okay, Control S, right? Now our address class is modified with one more variable. Now here goes the question. Right now if you have modified it, now in the app.java right here, whenever you will be creating an address, how you'll be creating? Right now we don't have any two argumented constructor, we have the 3 argumented constructor. So obviously I have to set a value here called India, right, which is going to be my country name, maybe US or UK or something, the country of that particular student. You have to give it here. Now the question is, whenever you are going to give it here, if you see now my problem is fixed. Now in the student.java we are getting another problem. Now imagine here in line number 26, whenever someone is going to call your getAddress method, you have to do what? You are creating a new address by using the address class constructor, and you are basically doing address.getCity, address.getState, and obviously right now we have added one more field to our address class constructor. So obviously we need to change this constructor as well. We need to say, we need to also do address.getCountry. We have to do that, then only the constructor will take 3 arguments, and right now my problem is fixed. But now you imagine if I'll go back to the previous state, my code was just like this, right? 2 parameter constructor. Right now imagine I have so many classes, just like student class, I have teacher class, I have attendant class, I have headmaster class, I have principal class, I have so many classes. In every classes, if I have used my address constructor just like this, it will be broken. The code will be broken. So I have to go to every class, and there I have to fix the constructor by giving it a new argument, just like address.getCountry. Okay, now this is not a good approach, right? I mean, changing your code again and again is really not good, right? Single responsibility principle, solid principle. If anybody remember, you must have known about this, right? When we make changes in one class, in the address class, if you are making any changes, that should not impact any other classes. You have to take care of that, right? That is the good coding design pattern. If I'm going to create another field here, private integer zip, right? Now if I'll be giving one more constructor here, what is that? Int, right? Int zip, right? And if I'm going to do this dot zip is equal to zip, right now the code will be breaking in every classes, and that is not good, right? If I do any changes to this address class, if my 100 of the other classes that I have, if they're also using this class, then obviously the code I have to fix there also. Now imagine 500 classes are using this address class, right? So everywhere right now, every class you have to go, just like your student class, every class you have to go and you have to fix the constructor. And that's not the right approach, right? Now let me go to the address.java. This zip is just to show you. Let me reboot back my code, and then I'll tell you a fix, a good coding approach. Now what you can do, you can just go to your student.java, right? Right here, you do not create the address object directly here. You remove all the parameters, okay? And right here, basically, you don't have to filter anything. You just send the address object directly. control click here, this address object directly, whatever the address object that you got here. So that address object, I'll be directly sending it right here. I'll be creating a new constructor. So new address, and I'll be giving the address object itself. And inside the address class, I will be doing what? I'll be creating another constructor. So address constructor, control space, create me an address constructor. And this address is gonna create an instance of itself. Okay, and I'm gonna do here only from this address, I'm gonna do what? I'm gonna use a copy constructor. So I'll say this. Basically, I am going to do what? I'm gonna call this particular constructor. To call this constructor, I need the city, state, and the country. How I'll be getting it? So basically, inside this address constructor, I'll be doing address, which is this one, right? Address dot get city, address dot get state, and address dot get country. All right, so basically what I did, I just created a new constructor which will take the address instance itself, and from here only I'm calling this constructor, right? In my address class I got this constructor, right? City, state, and country. That constructor only I'm calling here using this this keyword, constructor chaining. I hope you remember, right? So right now if I'll do click on this, you see it's navigating me to this constructor, right? So what I did here, right now if I'll go to the student.java, if I'll do control S, you see that basically the error is gone. So in the app.java, when someone is going to basically call the constructor right here of the student constructor, this home address, whatever the value of this home address, this one, this new part, whatever you got, this object will be stored here, right? Student.java, go there, this address will be whatever, right? You can see address is equal to new, whatever the value that you are giving, right? That object, this object, basically I'm doing what? I am sending it right here in the get method where I have get. Here basically I'm creating a new object of address. If I click here, that address object I'll be getting, and right here I'll be creating a new object. Okay, how I'll be creating a new object? By using this constructor. If you control click here, this is basically this constructor. I'm calling this constructor only inside the one argumented constructor, and I'm filtering with city, state, and the country, right? This is the solution for that particular problem, and this is a standard coding approach compared to the other one. So right now let me remove this comment part, and I hope your code will look exactly same as the previous one. Now if we'll go to the app.java and if we'll be running it, obviously you will be getting different objects here. And if you see right here, our immutable class property is not changed. Our class content, our object content is exactly similar as the previous one. And if you check, the content of our object is not changed, and our object state is not changed. And only thing that we have done here, the get address internal implementation, we have changed it to this much. This is the new constructor that we have introduced. Hopefully this is making sense. All right, so before we wrap up this particular session, this is not required, but another approach to solve this particular problem, maybe you will see it in your real-time code, the way they do it. Basically, if you go to your app.java, whenever someone will call your getAddress method, inside the getAddress, we are basically creating a new instance by using our address constructor. And inside the address, we just like this. Some people also create a getInstance method, a static instance method, just like this. Maybe you'll be seeing this kind of coding. So what they will do? Okay, some people will do it in this way. They will create a getInstance method. So basically, this method will give you the instance of an address, because you will be writing this method inside the address class only. So the address class will have a getInstance method which will return the address object, right? And here it will accept an address object also. So address, it will accept an address object and return, it will return what? A new address object. And here you can call your address class constructor address.getCity, address dot get what is that state, get state, and address dot get country. Okay, so I'm calling the address class, address class constructor. If you do a control click here, this is the constructor that I'm using, that I have inside my address class. And basically I am doing what? I am having a getInstance method, and this instance method will return an address object, and also it will be accepting an address object, and also it will be returning an address object. How it will be returning? Whatever the address object it will be receiving, with that address only it will be fetching the city, the state, and the country, and with that it will construct a new object, and it will give it back to you. And I will make sure to make it a static method. Okay, so someone doesn't need to create an object for this particular class to call this getInstance method. So right now, if you'll go to your student.java, right here in line number 25, instead of directly creating the object here, you can do what? You can do address dot getInstance, and you pass in your address instance just right here. And this address is obviously this guy, and obviously this address will be initialized, right? Whatever the value that we are giving from the constructor right here, copy that, paste it always if you don't understand this, right? This object will be initialized to this one. So it will be equal to, paste it here. Hopefully it's making sense. And this address, this object will go here to your getInstance, just right here, right? And in the getInstance, basically we are fetching everything from the address and creating a new object again of whatever the content we are getting out of that. Obviously, it should make sense. Just practice it one time and just let me know if you can replicate the same thing while you are coding it by yourself. But this is another standard approach to do it. All right, so before I wrap up this particular session, I want to come back to the question that I've asked you in the beginning of the tutorial. Your interviewer might ask you like, can you tell me the advantages, of immutable object? Now you told me like, how to create immutable object or how to create immutable class. What are the pros? What are the different scenario that you have to look after while you are creating the immutable class? That's fine. But what are the advantages, right? Okay, one advantage is basically the thread safety. The immutable objects are thread safe. Now how? Imagine the mutable objects. Now if there is a mutable object in a multi-threaded environment, then different threads can access that particular object in the same time. Imagine one thread is reading the data from an object and one thread is writing the data to that object. So maybe there is a chance of data inconsistency, because if someone is writing something while the other thread is reading, maybe the data inside the object will be changed. But if the object is immutable, then obviously we can guarantee that once the object is constructed, obviously the data inside the object will not be changed. That's the advantage, right? So even though 10 threads are accessing the same immutable object, we can be assured that that thread cannot hamper the data that we got inside that object, because that object is immutable. So once the object is getting created, these threads cannot change the data inside that particular object. So thread safety is one reason. The next reason, the immutable objects can be used as constants, right? Constants, just like the value of pi, the number of months that we have, of a year, the number of days that we have in a year. Those are called constant. Fixed value, right? The pi value will never change, right? I think you understand. So now the thing is that for the constant value, we can use immutable objects. All right, one more advantage is the immutable objects can be used as a key in the hash map. If you talk about your hash map key, whenever you create a hash map, you use key value pair, right, inside the hash map. The key is always immutable. You talk about string, integer, double, float, whatever you basically take inside your hash map, the hash map key, those are immutable objects, right? The string is immutable. The integer, the double, everything, the wrapper classes are immutable. What basically we use as a key in the hash map. So why is that? Okay, why okay, the benefit is obviously the immutable objects can be used as the key in the hash map, but why we use immutable objects as the key in the hash map, that is another question, and that is one of the most important question. You should not be ignoring this, and I will be discussing about this question more in the next video or in the next session. And one more thing, if you see here, we have the immutable object that we have created, which is student object. For now, let me remove all this value that I have initialized. This particular class, if you will see, you can see that this particular class is preceded by this final keyword. And why I made this particular class as final? You can say to the interviewer that, okay, this is final because I don't want somebody to extend this particular class. Then now the interviewer will ask, then what is the problem if you'll extend it, and how you think that your class behavior, your immutable class behavior will be changed if someone will be extending this particular class called student, which is obviously an immutable class. If I remove this keyword final from this class called student, can I use this class as a key in the hash map? Can I use this student class object as a key in the hash map? Right question, isn't it? So how this final keyword is making a difference? Very important question, guys. In the next session, we'll be discussing that. Yes, if someone is asking about the advantages of the immutable class, you can tell them about the thread safety. The immutable classes are thread safe. The immutable class can be used as a constant, okay, because the value of the immutable obviously will not change, and the constant value also will not change, just like the pi value. The third thing, the immutable objects are used as the key in the hash map, okay, and some more advantages. I'll be talking about that in the next session, and also I'll be giving you one of the very important questions answer, why the immutable classes are used as a key in the hash map. That's coming up in the next session. See you soon. Bye bye.